Hi, in this lecture, we are going to learn about k-nearest neighbors method, also known as KNN. First, let's see what is the characteristic of k-nearest neighbor. First, it is data-driven, not model-driven. Second, it makes no assumptions about the data, meaning the algorithm is a classification method that doesn't make assumptions about the form of relationship between the class membership and the predictors. The idea here is to identify K records in the training dataset that are similar to a new record that we wish to classify. Then we use these similar records to classify the new records. The basic concept here is that we denote the values of predictors for the new records by x1, x2, up to xp. Then in the training data set, we look for the records that are similar to the new records that we want to classify. Near here means the existing records that have predictor values close to the predictor values in the new records. Then we classify new records as whatever the predominant class is among the nearby records. The question here is how to measure the nearby. So first we need to know how to measure the distance. One of the most popular distance measure is Euclidean distance. The Euclidean distance between two records can be calculated by this formula. So if we have two records, records 1 and records 2, and we want to calculate the distance between these two records using Euclidean distance, this is the formula. And remember, typically predictors variables are first normalized to put them on comparable scale. Otherwise, matrices with large scales dominate. Now let's see how we can choose K. After calculating the distance between new record and the existing records, we need a rule to assign a new records to a class based on the class of its neighbors. And K is the number of nearby neighbors that can be used to classify the new records. The simplest case is K equal 1, where we look for the existing record that is closest and we classify the new record as belonging to the same class as its closest neighbor. And K equal 5 means we use 5 nearest records instead of 1 to find a class for the new records. Remember, typically we choose the value of K that has the lowest error rate in the validation data. Let's look at one example. A riding mover manufacturer would like to find a way to classify families in the city into two groups: those who are more likely to purchase a riding mover and those who are not likely to buy one. In the data set, we have 24 households classified as owning and not owning the riding movers. And a random of 12 owners, as you can see here, and 12 non-owners has been selected. Also, the income and the lot size are the predictors for this example. So first, we partition the data into training data and validation data, following the 60% and 40% rules. So we have 14 households for the training data and 10 households for the validation data. Obviously, this data set is too small for partitioning, which can result in unstable results or output. But we will continue with this partitioning for just illustration purpose. Second, we draw a scatter plot. So since this lecture is being recorded for the sake of time, please pause the video and practice the code. If you got any error in the code, please ask me in the next session. Before starting to write the code, first we need to import some required functions, as always. And here's the list of the functions that we need to use. Now we need to load and partition the data. And then we introduce the new household as a new record with 60K income and lot size of 20K square feet. Here. And here's the code for the scatter plot. This is the rest of the code for the scatter plot. And here is the output of the code. Having the scatter plot, if we look at the new household that we introduced to the model, also shown as black star here, with the 6K income and lot size of 20K square feet, we see that among all the household in the training set, the one which is closest to the new household is household 4, with 61,500 income and a lot size of 20,800 square feet. So if we use a 1NN classifier, which K equals 1, we would classify this new household as owner. Why? Because then the household 4 is an owner. If you look at here, the owners are illustrated by green color and the non-owners with the red color. So this is close to the owner. If we use K equal to 3, the 3 nearest household would be household 4, 1, and 14. And 2 of these neighbors are owners, and 1 of them is non-owner. Therefore, the majority vote is owners. And as a result, the new household would be classified as owner, right? Here's the code for normalizing the data based on the training set and finding the nearest neighbors to get the tabulated output. Here's the rest of the code. And please note that we are going to use K equal to 3 here because we are interested in 3 nearest household. And here's the code for getting the tabulated result for only 3 neighbors. Looking at the table and the scatter plot together, we can see that both of them are giving us the same result. So we can see that if we use K equal to 3, the 3 nearest household are 4, 14, and 1, and also in the scatter plot, 4, 14, and 1. And since the 2 of the neighbors are owners, the majority vote is owner. So the new household would be classified as owner. So here, 2 of them are owner. Here, 2 of them are owner. That's why the majority vote is owner, and the new household would be classified as an owner. Now the question is, how do we select K? And the answer is we choose the K with the best classification performance. And remember, we use the training data set to classify the records in the validation data. Then we calculate the error rates for the various choice of K. For example, if you choose K equal 1, we will classify in a way that is very sensitive to the local characteristic of the training data, because we are looking for only one class that is the closest class to the new record. And if we choose a large value of k, let's say k equals to 14, which is the total number of records that we have in the training data set, we would simply predict the most frequent class in the data set in all classes. Because we are looking at all the possible classes that we might be able to assign the new records to. So we need to find a balance. To find a balance, we examine the accuracy of the predictors in the validation set that results from different choice of k between 1 and 12. And remember, for an even number of k, if the value of k is even, and if there is a tie in classifying the household, we would, the tie will be broken randomly. Here's the code for measuring the predictor's accuracy for different value of k. And here's the output. We can see that the maximum accuracy with the smallest k, right, belongs to k equal to 4. So we would choose k equal 4, which maximize the accuracy in the validation set. And again, for even number of k, if the value of k is even, ties are broken randomly. We also can use k and n for predicting a numerical outcome. In this case, instead of majority votes determines the class, we use the average of response value. It could be a weighted average in which the weights decrease with distance, meaning the higher distance get the lower weights. There are some pros and cons for using the weighted average. The advantages would be, 1, it's simple. 2, no assumptions required about normal distributions. And finally, it's effective at capturing the complex interaction among variables without having to define a statistical model. And some of the disadvantages are the required size of the training set increases exponentially with number of predictors. And this is because the expected distance to the nearest neighbor increase with p. Because with the large vector of predictors, if we have too many predictors, all the records end up far away from each other. And in a large training set, it takes a long time to find the distance to all the neighbors and then identify the nearest one or nearest ones. But this results in the curse of dimensionality. It means that we need to deal with the high dimensionality. But fortunately, we can reduce the dimension of predictors using PCA method that we learned before, but still it's one more step that we need to deal with. So as a summary, in this lecture, we learned how to find the distance between new records that we wish to classify and all the other existing records. We also learned how to select the k nearest records. We classify it according to the majority vote of the nearest neighbors, or for prediction, we take the average of response value of the nearest neighbor. So that's it for k nearest neighbor. Please practice the codes and let me know if you have any questions. Have a good one and bye.